Some animals slither. Other animals ripple their body along the ground in an almost comic way. This toad can't jump, but rolls away from predators. And then, there is the most common strategy: walking. Even in this strategy of locomotion, there is an impressive evolutionary variety. There are 2, 4, 6, 8 and 100-legged creatures walking the earth. All of this got me wondering, why do some animals have more legs than the others? Why is it that small animals, and specifically only invertebrates such as insects and arachnids, have more than 4 legs? To better answer these questions, we need to go back 1.4 billion years ago, when the earliest signs of life started to appear. For a while, life was very squishy. Then, 558 million years ago, life split into 2 different skeleton stories. On one branch, the protozoans, creatures began to develop hard, protective parts around their full body. This structure is called an exoskeleton. Modern insects and arachnids are also members of this group of animals. But what does an exoskeleton have to do with the number of limbs? If a man had the power of an ant, he would be able to lift a medium-sized sedan, but there is a catch. If an ant was as big as a man, it would be crushed under its own weight. That means that the exoskeleton allows for these animals to carry much more than their body weight, but it also limits the animal's size. Another limiting size factor is that the animal must shed the external exoskeleton to form a new one. This often requires the replacement skeleton to be soft to allow it to escape the hard one. The soft exoskeleton then solidifies. The largest exoskeleton animal is the Japanese spider crab, with a maximum size of up to 12 feet, and the animal can weigh up to 44 pounds. So far we know that animals that have more than 4 legs have an exoskeleton and they are small. But how does this help you understand why they have more legs than other animals? Walking on 2 or 4 legs doesn't work well for animals of small stature. To help you understand that, I will bring a simple example from your childhood. I bet growing up, you tried to balance a long stick on the palm of your hand. It wasn't the hardest thing to do, right? Now, get a pencil and try to do the same. Isn't that much harder? In that sense, it works the same with balancing small creatures on just 2 of 4 legs. For that reason, most insects have 6 legs, and when walking they always keep 3 on the ground, forming a triangle to keep balance. Insects' evolutionary journey favored 6 legs. Ants can carry items with the front legs and still have 4 legs for balance and weight distribution. A beetle has 6 legs to stabilize all that rear weight. Climbing walls with 6 feet means more contact with the wall at any given time. Think of ants digging out a tunnel, or bees finding pollen, or a dung beetle rolling up poop. Think of a butterfly emerging from a cocoon, or a moth landing on a vertical surface. Every action is easier because of the multiple points of contact. Even flipping over if they're upside down is easier with 6 long, multiple-jointed, centrally anchored legs. There is also something interesting to be said for arachnids and their 8-legged setup. In short, they are extremely versatile. They can easily move backwards or sideways rather than just forwards, and all of this with little loss in efficiency. In addition, spiders can lose 2 or 3 legs and still be able to walk around just fine. They start to have difficulty walking if they lose more than that, but they can still pull themselves around to some extent. And on top of that, if it still has at least 1 more molt left in its life cycle, it's able to grow a new leg. You are probably thinking right now, how about millipedes? Don't they have like thousands of legs? Why have so many legs when snakes and worms have none? First of all, the millipede ranks as the animal with the most limbs on Earth, having up to 750. So, despite the name, they can't have thousands of legs. Millipedes, the same as insects and arachnids, are a type of arthropod. The last common ancestor of all arthropods had a segmented body, with 1 pair of limbs on each segment. It is exactly this segmentation of their body structure that made it possible for these animals to have more limbs. From an evolutionary perspective, it is easier to increase the number of the limbs when you have a segmented body structure. All you have to do is add another segment, and you have 2 more legs without messing up your whole body structure. On the other hand, humans and other chordates had long lost this kind of repeating segmented body structure. Once our bodies developed our head and the bone structure, there was no room or way to increase our leg count. After all, where would these new legs spring from? Our heads? Our stomachs? That is too hard evolutionary speaking, but losing legs on the other hand is way easier, and that is why we have snakes. Snakes lost their legs about 150 million years ago. It is still unknown whether their ancestors were aquatic or terrestrial, but it is very much known that the evolution of a long, legless body could be beneficial to life underwater, as it would enable eel-like swimming. But it could also be beneficial on land, making burrowing and hunting underground easier. At first sight, millipedes look similar to earthworms, but they are not the same species. Millipedes spend a lot of time in soil, under leaves or rocks, and their mighty limbs help them navigate such a harsh environment. Their head acts like a bulldozer, and with the help of their many legs, they push and dig into the dirt. Because of their legs, millipedes move much faster than earthworms. Worms, on the other hand, can't have any legs as they don't have any kind of hard skeleton structure. Instead, they use their circular and longitudinal muscles to move. Contrary to millipedes, earthworms can extend or contract their body, changing their size and making it possible for them to navigate through soil without the need of legs.